probably it's a very bad idea to explain jokes, but I think this is a very nice comic from xkcd where you can really learn about the subtleties of statistics. So here we have some physicist, and he says this neutrino detector measures whether the sun has gone nova. But then it would be a bit boring if it just always tells the truth. So it detects whether the sun has exploded or not, and then it rolls 2 dice, and if they both show a 6, it lies to us. So if the sun has not exploded, it says it has exploded. If the sun has exploded, it says it has not exploded. Okay, they try it out. The detector measures whether the sun has exploded, and then it rolls the dice, and it answers, yes, the sun has exploded. So how would you interpret this now? So the typical approach from hypothesis testing, as we have discussed before, would be called kind of the frequentist statistician approach. Now we would assume, let's be our null hypothesis that the sun has not exploded. If this null hypothesis is true, what would be the likelihood that our detector answers yes? This would only happen if with 2 dice we 2 times throw a 6. So the probability is 1 over 36, and that's 2.7% roughly. Now the interpretation here of a p-value would be, how likely is it to get such an result if the null hypothesis is indeed true, if the sun has not exploded? Then the probability would only be this 2.7%, so the p-value is below 5%. So we would reject the null hypothesis, we reject that the sun has not exploded, so we would accept, hey, the sun has exploded. But does that really mean that the probability that the sun has not exploded is below 5%? That's only 2.7%? Of course not. I mean, we would have some prior belief that it's extremely unlikely that the sun has exploded. So if we get this result that the machine says yes, it's probably because it has thrown 2 times the 6. So any Bayesian statistician who has some prior belief, who thinks it's very unlikely that the sun has exploded, wouldn't really update his belief very much by having this observation. He still believes the sun has not exploded, so he would really make a huge bet that the sun has not exploded. I mean, this is a very extreme example where p-values are misleading. We hope that in most cases, if we have a low p-value, it really means that the null hypothesis is quite unlikely. Only in some extreme case like here, where we initially think the null hypothesis is extremely likely, only in such cases we should not change our belief so much by having a low p-value. But if initially we thought, well, maybe the null hypothesis is true, maybe not, then the p-value is probably much more informative.